Hi everyone, welcome back. So I really want to show you the proof of one of them, and the rest is going to be similar. Okay, so last time we talked about for integral of sine to the n, we can split as sine to the n minus 1 and sine x, and we let u be sine to the power n minus 1x. And dv is sine x dx. Then du equals n minus 1. So this is chain rule. So we have sine to the n minus 2x. And u prime, derivative of sine is cosine dx. And then v integral of sine is going to be, because derivative of cosine is minus sine. So this is negative. And using the integration by parts formula, integral of sine to the n x dx is uv, so minus sine n minus 1x cosine x minus integral of v, but negative become positive, du. Do you see this Do you see this cosine x and cosine x together? So actually cosine square equals 1 minus sine square. So that's why this guy equals minus. Okay, so plus we can factor out n minus 1, and then we have, because cosine square is 1 minus sine square, so we have integral n minus 2 x dx. We can also split, and that is when we have sine square and this together, we have sine to the n x dx. So far so good. And this one I can move to the left hand side, combine with that one, so it become 1 plus n minus 1, so it be n of sine to the n x dx equals minus sine n minus 1x cosine x and plus n minus 1 integral of sine n minus 2 x dx. So now you can see I can divide both sides by n, then we get this formula. And the rest are very similar to this proof. Okay, so for our exam, you are not required to memorize these formulas. So I just briefly talk about, okay, we have this reduction formula. When you have a really big n, you can use this reduction formula to reduce the power. But in the exams, you don't need to memorize all this. You just use the way I taught you. Look at whether the power of sine and cosine, whether it's odd, and then use substitutions. Okay, everybody? So let's continue. The last type is integrating. We have products of sine and sine, products of sine, cosine, products of cosine and cosine. So the method is using these trig identities. Okay. By the way, these formulas are the only formulas I will provide you in the exam. Okay. So yes, these are the only one I will provide you in the exams, and possibly the Taylor series formula when we go to the chapter 9. Okay. So then the problems become pretty easy. So cosine, this is this guy. So we use this formula. Well, this one half cosine. Add those angles. So 3x plus 2x plus cosine, subtract those angles. Alright, and the 1/2 we can move it out. Then we have cosine 5x plus cosine x dx. Alright, let's continue. So what's integral of cosine 5x? Well, derivative of sine is positive cosine, so this is sine 5x, but divided by 5. And when you distribute, don't forget the 1/2. And integral of cosine is sine. So far, so good. We can also combine the 2 and 5 together. So this is our answer. Isn't it super easy? We just use this formula and then we just get sum or difference of sine and cosine, and then we can integrate directly using the sine and cosine formula. So far, so good, everybody. All right, let's see. Okay, so sine, cosine. So sine, cosine. Let's sine, cosine right here. So 1/2 sine add the angle plus 1/2 subtract the angles. Okay. So this is 1/2 sine add the angles plus sine subtract the angles. Alright, so 1/2 move it out, and then we have sine of 8x plus sine of 2x dx. Right? So some students forgot to integrate. No, don't forget to integrate. Integral of sine is minus cosine. And we also need to divide it by 8. Integral of sine is, don't forget to distribute the 1/2. So this is integral is minus cosine, but we have an extra 1/2 because of this. Alright, everybody. And so our answer is minus 1/16 cosine 8x minus 1/4 cosine 2x plus c. So far, so good, everybody. Okay, last we have sine and sine. So sine and sine is 1/2 cosine difference of the angles minus cosine add the angles. Okay, so this is 1/2 cosine difference of the angle minus cosine add the angles. So far, so good, everybody. So we can pull out the 1/2. This is cosine 6x minus cosine 8x. So far, so good. So integral of cosine is sine. And don't forget to distribute the 1/2. Integral of cosine is sine. And 2 times 6 is 12. 2 times 8 is 16. And that's it. So far, so good, everybody. And alright, we have a challenge example. Okay, let's see. See here, the power of secant is odd. Okay, and remember our rules. We have the integral of products of powers of tangent and secant. The first one is whether the tangent has odd power, okay? The second one is whether the secant has even power. In this case, no, none of those two cases. So the third case, which is the harder one, the tricky and harder one. So the method how to solve, it really depends on the example. Last time we see the example is the integral of secant. It turns out we multiply by the factor secant plus tangent, okay, by the numerator and denominator. And how about this one? Okay, let's solve this one. Okay, so what do I do is I want to try to split. Okay, here, do you realize secant squared is like is the derivative of tangent? Right? So I want to try to use integration by parts. And I let this be u. So u is secant x. So here we are using integration by parts. And and dv remains secant squared dx. So you always let dv be something you can integrate, okay? So integral of secant squared is tangent, derivative of secant is secant x, tangent x dx. Alright, and then our integral becomes uv minus integral of v du. So far, so good, everybody. And secant, tangent. Okay, what do we have here? We have tangent square secant dx. All right. Here, what do we do next? So here, actually, you can kind of relate this guy to what we had before, because tangent square, so here use the trig identity. So secant x, tangent square is secant square minus 1. So let's distribute it. So then secant cube. Okay, so we get this guy back, and that is good. Remember, we saw a couple of examples that we get it back. We can move to the left and solve it. And then we have the secant x dx. Good, because what we have is secant cube. Right, now I can move this guy to the left. So move this guy to the left. It becomes 2 copy of secant cube is secant tangent. And what's integral of secant? Well, this ln of secant x plus tangent x. And eventually, we can solve for secant cube. That's 1/2 secant x tangent x, and 1/2 ln of secant x and tangent x plus c. See, actually, look at this example. What method do we use? We use integration by parts. And we also use the trig identities. Okay? Yeah, that's why I said the third case is in general hard, because it really depends on the problem, and we use different methods. We don't have a clear guideline for it. So good news for you. In the exam, I will only test the first case and the second case, so you won't see the third case. What do I mean? So you might have the integrals products of the products of tangent and secant. You will see either the powers of tangent is odd or the power of secant is even. Okay, so you won't see the third case in the for the products of tangent and secant. How about sine and cosine? Of course, you will see. It's possible to see all 3 cases. Those are not hard. All right. So isn't it good news? Some of you might complain. Okay, if you're not gonna test in the exams, why do you teach it? Remember our goal. We are here to learn, not only for the grade. Your exams, because you only have 1 hour for the exam, we don't have much time. I cannot put more challenging problems on the exams because you don't have enough time to solve them. So that's why I have to limit the difficulties of the problems in the exams. But I really hope that I want to teach you like the all of these concepts. I don't want you to miss anything. Okay, so even though we won't test the third case in the exams, I still want you to know how to solve them when I give you more time. Okay, so have a nice day. Bye.